On March 11th of year 2011, tsunami generated by the earthquake of magnitude 9 hit Tohoku coastal area of Japan. A set of tsunami waves reaching in height 133 feet devastated large area, flooded and destroyed villages and towns. Water retreating back into the ocean induced millions of tons of floating debris. That debris was composed of small boats, mid-sized ships, houses, and a lot of lumber. It also included nets and floats from local aquaculture. 1 year later, we still do not have satisfactory network that would be able to monitor this debris in water. The only thing, just as 1 year ago, that we can do is to follow ocean currents. Fortunately, over recent 30 years, we collected a large number of trajectories of drifting buoys, which are essentially a scientific marine debris. Those buoys contain satellite transmitters in their surface containers, and their locations can be followed by satellites. And then, using our models, we were able to understand ocean currents. Dynamics of these scientific drifters is most close to such kinds of marine debris as derelict fishing gear and also microplastic that occupies wide range of depths in the upper ocean. Using these historical trajectories and after developing new diagnostic and statistical models, we are able now to run experiments under different scenarios. In our model, initiated with the nearly 500,000 computer points released in Tohoku area, we now can analyze motion of tsunami debris over a long period of time. What we can see clearly on these simulations is that initially narrow filaments of tsunami debris, they dispersed over a huge area and they drifted in many directions with general tendency towards the east. Results of our model are public and automatically updated on daily basis on our web page. On this map, you can see assessment of our model of debris location for today. This model solution reveals many peculiar features associated with the complex dynamics of tsunami debris. On the top of overall drift towards east, the leading edge of the debris cloud extends far east and currently is expected to be north of Hawaii. That is, tsunami debris cloud is now covering almost a half of the North Pacific. At the same time, there are countercurrents that carry this tsunami debris back towards Japan and other Asian countries. There are also eddies, these huge swirls of water that are capable of trapping floating objects for many months. Of our main concern is how this tsunami debris cloud is approaching Hawaiian Islands, and in particular Midway. To address this concern, in December 2011, University of Hawaii, together with Scripps Institution of Oceanography and Ocean Recovery Alliance, pulled together privately funded expedition. Our volunteer sailors sailed northwest of Midway Atoll in search for tsunami debris. After 2 months at sea, they only were able to report old plastic. They documented 175 objects, and many of these objects were brought to the university for further inspection. Based on these observations, combined with our model and with other satellite data, we understood that at the time of the expedition in December last year, pattern of currents was such that all Hawaiian Islands were protected by the flow, by the current flowing from southeast. This current was bringing a lot of old plastic from the center of subtropical gyre. Northwest of Midway, our model and satellite data reveal strong jet and strong temperature front, which at that time were protecting Hawaii from waters potentially occupied by tsunami debris. To track tsunami debris, to track motion of marine debris, volunteer sailors released 400 numbered wooden blocks and 11 drifting buoys with satellite transmitters that can be traced remotely. Future reports from people who may find wooden blocks, they will help us to understand better ocean currents and motion of debris. Since December, the pattern of ocean currents changed, and now debris, or better to say, water potentially occupied by tsunami debris, are approaching Midway Atoll. We are analyzing our data, and we are working together with volunteers on Kure Atoll and management of Midway Atoll to coordinate and to address this potential danger. Sooner or later, probably this winter, particles, our model particles, are going to start reaching Midway. Does it mean that real tsunami debris will start landing on Northwest Hawaiian Islands? It all depends on whether there is something in water and in what amounts. As I said before, unfortunately, we are still missing this part of information. All reports that have been received recently, they all come from random sources. Most of them are anecdotal, and most remarkable came from Russian sail training ship Pallada, who in September found and picked small Japanese fishing boat only 350 miles northwest from Midway. Later, this boat was proven to be registered to Fukushima Prefecture, and Japanese TV companies found the family of the owner of the boat and confirmed that the boat was lost at the time of tsunami. Remarkable change over the year is that when in the beginning tsunami debris was seen as thick mats of everything mixed together and floating on the surface, and many of these mats were of yellowish color because of lumber from broken houses. 1 year later, you can hardly see two floating objects from tsunami debris at the same time. Debris is largely dispersed over a huge area. Recently, Japanese government, the cabinet of Japanese Prime Minister and its secretariat made public the web page where they report observations from all kind of ships of large objects floating in so-called navigation area number 11, which is west of the dateline and south of 45 degrees north. Most of these reports are on objects that may be hazardous for navigation, such as boats, ships, freight containers, and also large pieces of lumber and timber. Some of these reports are accompanied by photographs. These photographs show boats and ships as well as wood that is surprisingly still afloat. Combined together, reports collected on the Japanese website, they form a pretty impressive cloud of observations. On this slide, we show the timeline of these reports with colors indicating the months when observations were reported. Our map shows that early reports shown in blue correspond to western side of the area, and yellowish and brownish later reports mainly correspond to the eastern part of the area, but not exactly. Everything is pretty well mixed together and moving in many directions. We continue building our partnership with many companies and universities owning training ships and research vessels. This photograph shows recent reports from a fishery training vessel Ryasu Maru from Japan, which again confirms that in December some wood was still floating. Important question is, what is the future fate of tsunami debris? Using historical data from 13 years of drifting buoys, we assess that tsunami debris cloud will continue drifting towards east. This winter or this spring, it will start showing up on northwest Hawaiian Islands. Next year, approximately 2.5 years after tsunami, its leading edge will touch US-Canada west coast. But before the main mass of debris will start landing on the coast, this mass will actually recirculate southward towards so-called North Pacific garbage patch, which is the convergence area located between Hawaii and California. The main mass of debris will reach garbage patch in approximately 4-5 years after tsunami. This motion is consistent with the pattern of surface currents revealed by tsunami debris. These currents, they consist of strong western boundary currents, equatorial currents, jets of the Southern Ocean, and also swirling anticyclonic gyres in all 5 subtropical oceans. Our modeling of general circulation of marine debris revealed 5 garbage patches in all subtropical oceans, and all these patches are for now confirmed by direct observations. The strongest patch containing the largest amount of debris is in the North Pacific. Unfortunately for Hawaii, because ocean currents are not steady but experience many many different types of variability. Debris collected in the garbage patch does not stay in the middle of the ocean forever. Time to time, this debris leaks from the area, and when it happens, it always goes towards Hawaii. This is confirmed by trajectories of drifting buoys showing on the lower panel. After reaching Hawaii, some debris ends on our beaches, and some sneaks between the islands and returns back to North Pacific garbage patch until the next opportunity. This means that Hawaii is going to be hit by tsunami debris twice. One time directly as debris is drifting north of Hawaii, and second time on the long run when decomposing debris will mix with the older plastic collected in the gyre. Our model, our study, does not cover all types of debris. Recent reports from West Coast, from Washington, British Columbia, Oregon, and Alaska indicate that light, large objects such as 55-gallon floats from Japanese oyster farms already started showing on US West Coast. More than 250 reports were collected by Curtis Ebesmeyer and his colleagues. Although for each object found on our coastline, it is really difficult to obtain a solid proof of its origin from Japan and from tsunami. Massive appearance of unusual objects indicate that these floats are indeed product of last year's tsunami. To summarize the current status of tsunami debris in the North Pacific, according to the estimate of Japanese government, tsunami generated approximately 25 million tons, including large amount that was washed into the ocean. Probably best estimate of marine tsunami debris ranges somewhere between 4 and 8 million tons on first days after tsunami. For now, from different estimates, from different studies, rough estimate of the amount of debris that is still floating in water is somewhere between 1 and 2 million tons. Importantly, density of this debris in water is now very low. It is difficult to observe these objects because they are dispersed over huge area. However, it does not make this debris less dangerous. Good news that comes from results of our study is that only a small fraction of this floating debris is going to end on the coastline. 95–98% of floating debris is going to collect in the garbage patch area and remain there for a while. This will buy some time for the ocean to grind and sink down a big part of that debris. To answer the question, which areas, which coastlines are going to be affected by tsunami debris, the answer is those are the same areas that are already affected by common marine debris. These areas include Oregon, Washington, British Columbia, Alaska, and Hawaii. California is less affected by marine debris and is protected by the coastal upwelling. Now, tsunami debris is dispersed over a huge area, and it is nearly impossible to collect it all. At the same time, our study shows that we have a chance to focus on the debris drifting towards our coastlines. This debris is not random. It follows narrow corridors, and these corridors can be used to monitor and to intercept dangerous kinds of marine debris. In addition, this tragic event of nature should be used to improve our understanding of general dynamics of marine debris and to improve our system addressing this problem. Tsunami debris is going to mix with the larger amount of common debris already existing in the ocean. And this problem will remain for many years to come. At the International Pacific Research Center of the University of Hawaii at Manoa, we continue working together with other universities, companies, and agencies to improve our understanding of dynamics of tsunami debris and setting up the system to monitor its motion. Please follow our progress on our public web page, the link to which you see on your screen.